Hello, guys. Welcome to 100 Days of Multimodality in AI in Healthcare. Today is day 2, and I would be focusing on explaining what is multimodality in healthcare. So, you know that biomedical data can be of different types. Maybe you could go to a doctor, he would do some X-ray or MRI scans, or you just have a health record like data, or you the doctor, the nurse can just take out your blood and do some kind of genomic analysis from that. Or maybe you get some fancy ECG machine or EEG data being collected from your brain. Or maybe just kind of optical signals being collected from your tip of the thumb. So these kind of different modalities uh, can be taken together for understanding the overall patient healthcare condition. But the major challenge in real world application is that for a given patient, let's say, the all the type of data may not be available, and also for each of the data points, it may be collected at different times, which may not correlate together. But it can be integrated, and the time correlation can be mapped accordingly. So before going deep into each of these modalities developing into AI systems, let's think about doing some exploratory data analysis of each of these unimodal datasets. So this kind of data engineering problem is being handled by data curator, signal processing engineer, or a data engineer altogether, who ensures that the data which they have is being curated accordingly. It's cleaned and adequate for the AI engineer to train a robust model. So, in this first class, we would focus on one fundamental modality, which is electronic health records, EHRs to be short. So, these EHRs stores data in a structured format, standardized format, whether it's FHIR, which is Fast Health Interoperability Resource, or OMOP, which is Observational Medical Outcome Partnership. So, for our purpose, let's not go deep into what these kind of standardized formats are. Let's deep dive into the like code implementation of these. So here, let's start with FHIR. First comment what FHIR is, and automatically in the Jupyter Notebook code, in the VS Code, you get different suggestions for that. I would go through these suggestions, but I don't need XML format, so I would delete that. I just need JSON, and I would import JSON format and again import date time, and from that I would import date time and time delta. And because I'm generating a random patient data, so I would have to import random. And the first instant is I have to create a class called FHIR patients if I want to create a synthetic data, and here boom, here's the suggestion for that. I have to initialize the function here, like which include patient ID, name, birth rate, birth date, and gender. And for each of these parameters, I would just optimize it. Like for the name, I include first and last name, and for the gender, I just converted whatever the value inside a variable to lowercase. And I had to convert this into JSON format and return the function in JSON. So I would all the parameters which are there, I would just list those parameters, and the values inside these will be given in the objects. So gender, it I would include the gender here because the session didn't give me this gender. I would just remove this and create like another class for the EHR data, which is this OMOP processor, and define different functions here, which like initializing the conditions which include different diabetes, hypertension, asthma, and different conditions having different IDs. And then I would define the race for each of the patient which are there, and create the patient record which include patient ID, name, birth rate, and race. Yeah, gender and race. So here I had to return these all parameters which are there. And so while I create an object for this, then I would be getting these different uh, different kind of parameters there. So here I included the ID for gender. If it's 8507, it's male, otherwise it's female. And even for the race, then it would like concatenate from that of the defined map race function which I have used earlier. Then I would create a condition occurrence for the patients which are there, if it's like condition for each of the patient IDs mentioned. So condition name and the when did the condition occurred. So if the condition is not there in the data set, then just pop up the value error that this condition is not recognized. Otherwise, just return whatever the values are there. So I would just run this. Oops. So here, like, I should write from date time import. It's uh, yeah, from date time import date time and time delta. I have written as here. That's So now I will create synthetic data, like include each of the values here for each of the parameters, and then create a for loop for each of these parameters, and and create a variable FHIR patient with with the class function, which is the like the FHIR patient is an object to that class function, and even person will be then object for OMOP processor class function. So here I have like created different kind of conditions, and then uh, just write a function to append the patients for at uh, for, uh, for the data set, for generating this data set, like uh, FHIR, OMOP patient, and the condition of the patient, what is the race, gender, and different parameters I did include here. And once I complete this function of like appending different like values to these parameters, then I would just include the birth year, like splitting the birth date uh, like as year, month, and day. So the index 0 indicate the year, so I would return the function as patients. So after doing that, I would then go to exploratory data analysis, where I need few of other libraries like pandas, matplotlib, and then I would define the patient size here, like the number of patients as 15 from the, and then like create a data frame of these patients, which I would again go for what the data frame should look like, the columns for that, and these columns include the patient ID. I would not go for OMOP, I will go for FHR ID and like the patient ID here, and then different other parameters I do include here, like name of that patient, uh, gender of that patient, race of that patient, and um, the condition he is having. So here you are wondering what P is. P is just the patient here. I will define it later, and the birth year and the condition he is having. So for P in patients, so you can have any other variable like X or I here, but P means for patient, so that's why it's more convenient. And if you now if I run this code, I would get this data frame, like first 5 instances of this data frame, and I would further go for plotting a few of these exploratory data analysis visualizations. So for that, matplotlib is pretty much like helpful in this, and I would just print. I'm doing a descriptive statistical analysis for this. So it's descriptive statistics. Yeah, this is different from what inferential statistics is, which is more like valuable in later machine learning tasks. And I would just import few of the like column here, like what is the condition here with respect to the condition. I would give different color for each of these conditions and see which condition is more prevalent, and just label the x and y variables here, like x and y axis, and just see what will be the plot for this. And at the same time, again, I would do data frame for like I would import, see which gender type is more prevalent here in this data type which I have generated, like random generated data type. So again, I would give different colors to each of these values of the gender variable. So here, like the values may be male or female here in this gender case, and for the condition it may be like different disease conditions. So this plot is being generated here, but I do want to change the color of it. So I will just go and create a kind of a list here which include different colors. Like light green was already included, I would just include red. And here again, color, like 3 conditions were there, and I would include 3 different colors for these. So I would recommend that try it out yourself for getting hands-on experience in that. And in the next video we would go for the real world data.